Okay, so today we're going to be doing stoichiometry. So stoichiometry is basically just multiple ratios using dimensional analysis. So canceling out your top and your bottom terms. So we have potassium plus chlorine. Okay, so we see how this is imbalanced. So let's go ahead and balance this. Let me just get a different color marker. So we have 2 chlorines here, so that means we need 2 over here. But then potassium gets 1. So then we have to add 2. Okay, so now it's balanced. So now we can do our multiple ratios. So whatever this number is in the front, that tells us how many moles we have of that particular atom. So I'm just go ahead and write that. We have, those are our moles. And then the number after this number, I guess it's just here, it tells us the mass. So that means we have 2 chlorines, okay? Okay, so we are going to do this problem. So we have 2.50 grams of potassium, and we want to find out how many grams of potassium chloride are there. So we know this is a gram to gram ratio problem. Okay, so we always want to start with what they give you. So we know we have 2.50 grams of potassium. Okay, and we need to find, we have 1 mole for every, now we have to go to the periodic table to see how many, what's the mass of potassium. So potassium has 39.10 grams. Okay, so you see how we needed grams on the bottom to cancel out the grams. So now I can go ahead and cancel out my grams. Now I want mole to mole ratio. So then I get my moles of potassium and my moles of potassium chloride. And this is 1 mole of, okay, so I want my potassium on the bottom. So I'm going to go ahead and write that so I don't forget. So if we look here to find our multiple ratio, we look at the number in front of it. So we have 2 potassiums. So 2. And then we look at, we want potassium chloride, we also have 2. So then we have 2 moles of potassium chloride. And we need to keep on going because we just canceled out our moles, so we're left at moles, but we don't want moles, we want grams. So now I have to find the grams of potassium chloride. So for every 1 mole of potassium chloride, I look here, I don't have anything at the end, so I know it's just 1. So I have to look at the mass for potassium, which is, I found it over here, 39.10, plus chlorine. So chlorine is 35.45. And that's how many grams of potassium chloride I have. So then I can cancel these cancel, and I'm left with my grams for potassium chloride, and that's what I want. So now I just simply put that into the calculator. Okay, and it's 4.77 grams of potassium chloride. And we look at 3 sig figs because we have 3 sig figs. These are exact. Okay, We have 4 moles of potassium chloride, and we want to find out how many grams of chlorine we have. So it's a mole to gram ratio. So I'm going to write that here because we're going to start with our moles and we're going to go to grams. We're not going to stop until we get to grams of Cl2. Okay, so I'm going to start with what they give us. So we have 4.00 moles of KCl. So we have moles. So I'm going to take how many moles I have of KCl, and I have 2 because the number in front tells us how many moles we have of that atom. So we have 2 moles of KCl, and then we have how many chlorine we have. We just have 1. So over 1 mole of Cl2. Okay? Now I can cancel my moles out. Now I still need to go to grams. I'm not at grams, I'm still at moles. So then for every 1 mole of Cl2, I have to look at my periodic table to see how many chlorines are there. And don't forget the number behind it tells us how many we have. So we have 2 chlorines. So 2 times however many we have, and we have 35.45. Oops, 35.45 grams of Cl2. So now we can stop because we got 2 grams and we got to how much we needed. So now all I have to do is put it into my calculator, cancel out those. So we have 1, 4, and then I'm going to round up 2 grams of Cl2. So when doing an experiment, you're going to want to find your percent yield. The formula for percent yield equals the actual yield, which is what you got in your experiment, over the theoretical yield, which is what you're supposed to get if it was a perfect world, times 100. So let's say we had 53.22 grams as what we got, our actual yield, over 85.25 grams. That's what we're supposed to get, times 100. If the actual yield can never be bigger than your theoretical yield. If that happens, then you need to redo your experiment because you did something really wrong. So then I'll just put that into my calculator, and I know I need 4 sig figs, so it's 62.43%. So this ends my lesson for stoichiometry, and I hope it was very helpful.